Ladies and gentlemen, welcome to the Intelligent Data Center session. This session will focus on Huawei's Intelligent Data Center that offers flexible architecture and innovative technology. Thanks to more than 30 years of expertise in the ICT field, Huawei offers services that cover the entire data center process, ranging from network construction to O&M. At Huawei, we build intelligent, efficient, and green data centers that drive industry digital transformation. Next, let's look at the key components needed to build a future-proof data center. Computing is one of the most important features for data centers. Now let's welcome Mr. Tang Qiming, Director of Huawei Computing Product Line. He will explore the concept of unlocking efficient computing power for data centers.
Hello everyone, I'm Tap from the Computing Product Line of Huawei. Today, I would like to share with you how to provide the more efficient computing power for data centers. According to the IDC report, the digital economy is the engine of the GDP growth. What does it mean? Well, the economy based on the computing technology is overtaking all others. Most commerce is being digitally delivered or enhanced, including the product, service, and experience. All enterprises need to process data, and digital enterprises use data centers to store, communicate, and transfer data without latency. This also uses data centers to solve energy uses, performance, and confidential data protection issues. Greater computing power in these data centers enable more rapid collections of larger diverse data sets, provide the faster performance of intelligence and big data analytics, and deliver the flexibility and efficiency needed to accelerate the digital economy. Computing power is therefore an accelerator of the digital economy. Huawei GIV 2025 predicts that the world will have generated 180 ZB of new data, or 18 times more than in 2018. 80% of this data will be unstructured, requiring a higher performance computing and storage. Let me show you some examples. Huawei's internal IT system consists of more than 1,290 application modules. These modules generate two types of data, OLTP and OLAP. The volume of the transactional data is about 10 PB, which supports companies' main business transaction flows for digital transformation. The volume of the analytical data is about 40 PB and grows by 1 PB per month. Another example is the city of Shenzhen that has deployed over 2 million cameras. These cameras generate 80 PB of data each day, which is stored for 30 days or even longer. These cases show that there's a lot of data being generated out there, and its volume will never stop growing. However, the statistics tell us that we use only about 10% of our data and store less than 2%. This means that we have yet to tap into the real value of the data. But to maximize it, we need to grow our computing power. So the question is, how can we improve the computing power? The answer is twofold. First, we need to improve the performance of a single server, and then we need to improve the deployment density of data centers. This means that to increase the computing power, we need to improve the computing density. However, traditional data center will face many challenges due to the higher computing density. Firstly, there is a bottleneck in terms of computing power. Server performance relies heavily on the CPUs and fails to meet different computing workloads. The second challenge is inefficient operation and management. Traditional data center relies on manual maintenance, leading to the low OM efficiency. High cost represent the third challenge. L1 and L2 are lack of linkage in data centers, leading to the high power consumption and cost. To address this challenge, we will upgrade traditional data centers, applying 3 solutions to make them smarter. First, equip data center with intelligent servers that provide efficient computing power for different workloads. Second, improve the deployment density to build high-density data center clusters. Third, link L1 and L2 to achieve a fully intelligent data center. Now, let me delve into the details about these solutions. As I mentioned, to handle the gross computing power requirement, we need to improve the single server performance and the deployment density of data centers. Huawei believes that we need to address the Intel system to improve a single server performance, instead of focusing only on the processor alone. Huawei endeavors to improve the performance throughout the entire process, ranging from device boot to efficient operation. In terms of CPUs, we keep pace with Intel by equipping our next-generation servers with the latest Intel processors. For system boot, Huawei adopted innovative boot speed-up storage technology, BEAST, to improve boot speed by 3 times. In terms of network performance, the intelligent NICs in 200 and in 300 free up to 15% of processor resources by offloading the network protocols. And as for heterogeneous acceleration, we have developed Atlas 300 to integrate intelligent capabilities into our general-purpose servers. Together, this approach maximizes the performance of our Fusion Server Pro series servers. To improve the deployment density of data centers, Huawei has launched the FusionPod Rack Scale Server. It is a brand new product that redefines the heat dissipation and power supply. In addition, it is the only product in the industry that supports blend-made connectors for 3 types of cables: power, liquid cooling, and Ethernet cables. FusionPod is easy to deploy and maintain, and features high-density computing and energy efficiency. Therefore, it is ideal for large-scale scenarios, such as HPC. FusionPod adopts integrated liquid cooling technology. This can dissipate 80% of heat using liquid cooling and 20% of heat using air-to-liquid heat exchange. FusionPod implements full liquid cooling for the entire cabinet. With this technology, we do not need to install all the air conditioners in our data centers, reducing the PUE to 1.10. Compared with the air cooling system, our design improved the power by 4 times, so as the deployment of density of a single cabinet by 4 times. In summary, this product is ideal for building higher density data center clusters. As the number of servers in data centers continues to grow, OM challenges also increase. Customers look into improve their OM efficiency and reduce OM cost. In response, Huawei has introduced 5 intelligent technologies to make OM more efficient and cost-effective throughout the network lifecycle. For example, our intelligent maintenance technology could help predicting a hard disk fault 7 to 30 days before it occurs, preventing servers breakdown and other network accidents. In terms of the saving energy, we have introduced the energy-saving technology for devices, cabinets, and data centers. For devices, we offer dynamic energy management technology, which detects the operation status of the upper layer servers and adjusts the power consumption of server accordingly. This helps reduce the power consumption by 15%. Every year, when Intel releases their latest processor, Huawei launches a next-generation server running on the latest Intel technology. This strategic partnership has lasted for 20 years and will continue in the future. Currently, our mainstream servers are the Fusion Server Pro V5 series. All the V5 series servers are equipped by the 2 cutting-edge Intel technology, the latest Cascade Lake refresh processor. In addition, all V5 series servers will evolve to next-generation V6. In June 2020, Huawei released the Fusion Server Pro 2488 HV6. This is a full-socket server running on the third generation Intel Copper Lake processor. In April this year, we will launch more V6 series servers. For years, Huawei has worked in close partnership with many vendors, such as SAP and VMware. To date, Huawei's new Fusion Server product has been certified for the SAP HANA solutions. Huawei has also completed the related certification for the VMware vSAN solutions. In this way, we can provide our customers with all-flash storage servers and hybrid storage servers. Huawei's computing product and solutions are highly recognized by top customers across the industry worldwide and has been chosen by 211 companies on the Fortune 500. In particular, this product and solutions has attracted 3 of the world's top 5 banks and 4 of the world's top 5 automobile manufacturers. Huawei also serves top internet and energy enterprise worldwide. Adhering to win-win cooperation, Huawei joins hands with the industry chains and partners to provide the best-in-class service across the industries and drive the digital economy with higher and more efficient computing power. That's all my presentation. Thanks for your time.
Thank you, Mr. Tang, for your detailed thoughts. Rapidly growing services and data volumes brought by industry digital transformation will impact the storage system. The question is, how can enterprises build a green, reliable, and intelligent storage system to release the real value of data? To answer this question, Ms. Amy Liang, Vice President of Enterprise Data Storage Technical Sales Department, will share her thoughts on the topic, moving towards an all-flash-powered data center. Let's welcome Ms. Liang.
Ladies and gentlemen, I'm Amy Liang. Today, it's my great honor to share with you of the next topic, moving towards an all-flash-powered data center. As we can easily judge, the world is fast diving into a fully digitalized era. In the past 10 years, the whole data amount has increased several times. And with the explosive growth of internet traffic, in next 5 years, the amount of data to be stored will increase from 32 zettabyte to 180 zettabyte by the year 2025, among which the unstructured data will account for more than 80%. Like in the agricultural economy age, the land and the labor were the primary production factors. In the industrial economy age, capital and technology became important factors of production. Now, with the advent of the digital economy, data is a core means of production. Take digital interconnected factories as an example. The data volume is easily increased to PB level, and to develop one model of self-driving car, at least 64 terabytes daily training data will be generated per day. The data explosion drives the maturity of the data volume chain and further drives enterprise decision-making and innovation to generate digital dividends. Thus, we need powerful digital infrastructure to capitalize on data during this transformation. Most of the data infrastructure are installed in data centers, like servers for computing, switches for data exchange, and storage for data reservation. In light of explosive data growth, diverse data types, and the ever-increasing importance of it, data centers face the following challenges. First, the service pressure becomes higher and higher. The digital transformation of enterprises drives huge amounts of offline services to go online. And innovative services are emerging one after another. Online and diversified services result in more than 10 times of peak loads, which requires high reliability. This is amplified by the finance sector, especially due to the e-commerce and mobile payment. During peak hours in China's Double 11 shopping festival, the transactions per second of a large bank increases from 3,000 to 30,000. Second, with the data volume and application increase, data centers are getting larger, and the total amount of small and edge data center grows. Data centers have become a major power consumer. Currently, the total global power consumption of data centers costs around 2 to 3% of the annual world power consumption. And the power consumption will reach 42% of the total ICT consumption by 2025. High energy consumption results in high electricity costs. In fact, electricity costs account for 60% of the total TCO of a data center during its 10-year life cycle. Another consequence to consider is the high carbon emissions. The global carbon emissions of data centers are equivalent to those of the aviation industry and account for 60% of the total energy consumed by the digital ecosystem. According to the United Nations Environment Program, global emissions must fall by 7.6% per year for the next decade to meet the 1.5 degrees centigrade goal. The European Union is committed to achieve zero carbon emission by 2015. There is still a long way to go for data centers to save energy and reduce emissions. Third, as data becomes more and more important, data center shutdown becomes unacceptable. Statistics show that nearly 1 million enterprises go bankrupt every year due to data loss. And the loss caused by downtime in the financial industry reaches up to 6.48 million per hour. 4. There are also other costs to consider. A data center with 1,000 racks usually has over 100 types of device, and information about dumb devices is not transparent, which increases the difficulty in fault location and related service response. Due to a large number of vendors and interface, the training cost of operation and maintenance personnel are high. As a result, 61% of data centers lack qualified O&M personnel. By 2025, the amount of data maintained per capita will increase fivefold, which further increases the difficulty of O&M and labor costs. All the challenges will require an upgrade on data center technology, not only of the media, but also the integration of data center resources and reconstruction of the architecture in order to meet diverse future service requirements. Specifically, the all-flash data center solution covers all-flash upgrade for the whole IT infrastructure, flash-based servers, NVMe native all-IP data center network, all-scenario all-flash storage, and full lifecycle intelligent O&M for multiple data workloads. For storage ledger, the upgrade has 3 key characteristics: all-scenario flash, full series high-end quality, and all-scenario data protection. It helps build a greener data center with higher efficiency and availability, more intelligent O&M, lower TCO, and zero network bottleneck. All scenario flash have 2 meanings. The first is that diverse types of data are willing to be stored in flash media-based system. Not only the data from enterprise mission-critical applications, but also those data from edge, HPC, big data, and other systems. The second is that from primary storage to secondary storage, like backup appliance, HDDs should be replaced by SSDs to enhance the performance while reduce the cost and power consumption. All scenario flash delivers 2 benefits: cost reduction and efficiency improvement. Offering the same capacity, SSDs reduce power consumption by 70% and space by 50% than SAS HDDs. This slashes the TCO of data centers and helps them to go carbon neutral. In terms of procurement costs, IDC statistics show the unit price of SSD is now lower than SAS HDD by introduction of deduplication and compression functions in storage system. So we already see the SSD shipment proportions increases year on year, and replacing HDDs has become an inevitable trend in primary storage scenarios. And from 2020 to the next 5 years, along with the usage of several types of new low-cost media like QLC-NAT, the secondary storage will also change to flash-based. Here we got an example. A bank changed their total 10 cabinets of storage to 4 cabinets of flash storage. The performance increased by 150%, saves 60% of space and power, and 50% of manpower since all the technology are similar from no big difference between systems. Well, all scenario flash transformation also requires high-end quality for both high-end storage and mid-range storage. Take banking industry service as an example. Traditional core services include payment and transfer, daily settlement and monthly settlement, card issuing, and wealth management. Such data requires over 6 nines availability, million level IOPS at a latency of sub-millisecond per device, as well as both high scale-out and scale-up capabilities. With the advent of the Bank 4.0 era, the friction-free model developed intermediate business and intelligent services blur the boundaries between core and non-core services. Fast mobile payment and ubiquitous financial services drive higher service processing requirements. Take a typical medium-sized bank as an example. The bank requires 24/7 service continuity. It has seen a 10-fold increase in transaction frequency and a 40-fold increase in daily data volume, from 50 gigabyte to 2,000 gigabyte. So here's the conclusion. Facing the uncertain, fast-changing future, even mid-range storage needs to offer high-end quality to address higher service demands. Now, let's look at the comprehensive data protection solution. It has 3 aspects. Disaster recovery mechanism to create an active or passive full copy for the source data. Backup mechanism to create several time-based copies for the source data. And archive mechanism to move source data to a longer retention media and make copies to protect it. In short, when building an all-flash data center, those 3 mechanisms should be considered. There's a challenge leads to cost efficiency, faster solution. During the last decades, data is more and more used for mining and big data analysis. The life cycle of data stay in the main storage system is prolonged, and the volume of data retention and protection is enlarged according to the demand. But the time window and budget for data protection didn't change or become even less. By introducing local active-passive function to replication to the cloud, the system availability improved. By adding flash disk into backup storage and improve the data reduction ratio, the huge amount of data is able to be fast backup within a certain time window at low cost. Traditionally, in the data center, fiber channel network is the last specialized network used dedicated for connection between server and storage. Now, all-scenario flash is driving the storage media interface transform from SCAS to NVMe, which calls for a faster, reliable network. Currently, normal fiber channel network speed is 32 gigabit per second and 64 gigabit per second. Comparing with Rocking network 25G, 15G, 100G, it is theoretically much slower and not able to unleash the power of flash storage. That brings us to NVMe over Rocky storage network. NVMe over Rocky is an easy-to-manage model that uses IP network to provide 10 times higher throughput and lower latency than fiber channel. The NVMe over Rocky solution is the best solution for implementing an end-to-end NVMe storage network. An all-flash data center should have full lifecycle intelligent O&M capabilities. That is, automatical and intelligent capabilities are available in all phases of planning, provisioning, O&M, and optimization. Intelligence and big data technologies are key to improve data center management. In the planning phase, resources are preciously planned, and the focus has shifted from device upgrade to full lifecycle data management. In the provisioning phase, global resources are automatically provisioned. In the O&M phase, full-stack intelligent O&M is implemented to change reactive inspections to proactive discovery. In the optimization phase, agile configuration optimization and automatic resource prediction and change are implemented. The optimization is performed using intelligent algorithms instead of expert experience. Today, we are glad to bring you the Huawei all-flash powered data center solution, which is business-enabling, green, reliable, and intelligent. The solution consists of OceanStor all-flash storage series as primary storage, Ocean Protect series as data protection secondary storage, NVMe over Rocky storage network either from Huawei or other vendors, and DME full lifecycle intelligent O&M. Huawei OceanStor all-flash storage is very suitable for serving the core application systems in a wide range of industries like finance, carrier, medical care, and manufacturing. It delivers industry's highest 7 nines reliability. The storage tolerance failures of 7 out of 8 controllers and the failure of a single controller enclosure without service interruption. Moreover, SSDs yield at 5 years return rate of just 0.8%, which is 10 times lower than HDDs. When it comes to performance, the OceanStor all-flash storage delivers the industry record 21 million IOPS under typical frequent used I/O patterns. The performance with various features enabled has only less than 10% impaction. For example, when data reduction, garbage collection, read-seeks, and snapshots are enabled, the performance of our storage decreases by only about 10% and remains stable. In contrast, the industry average performance of other vendors' storage decreased by 40%. In terms of availability, the OceanStor all-flash storage provides 100% data availability guarantee and flash-ever hardware subscription model to the customer to protect the customer's invest. Huawei Ocean Protect provides customers with all scenario data protection. We provide a comprehensive solution that protects data throughout its lifecycle, from data generation, use, to destruction. The overall solution that includes disaster recovery and backup helps our customer achieve disaster recovery of production data, backup of critical enterprise data, and valuable data reuse. Huawei Storage provides various disaster recovery features, such as active-active, active-passive, and 3DC solutions. and uses OceanStorm BC Manager for unified, intelligent, and simplified disaster recovery scheduling and O&M management. In the backup scenario, we provide both centralized backup solution and all-in-one backup appliance to allow customers to collectively or separately deploy backup storage and media to meet different customer needs. We fully understand the main purpose of backup is to recover the data when needed. Our Ocean Protect backup appliance has the fastest speed among all the vendors. And we are working on helping the customer reuse the backup data directly from the backup appliance for like test and validation scenarios. As I mentioned in the previous slide, the trend of storage network now is changing from FC only to NVMe over Fabric. And IP-based storage network has big advantages on both speed and cost. However, the IP network often encounters packet loss. When SSDs are used in the IP network, the storage IOPS increases and the Ethernet network pressure grows, causing the packet loss rate and the network latency to surge. To address this issue, Huawei intelligent IP switches use an innovative lossless algorithm to dynamically adjust the threshold, greatly reduce packet loss and ensuring consistent low latency of the storage network. The all-IP NVMe over Rocky network reduced the average latency by 42% compared with the fiber channel network, achieving an end-to-end latency of less than 50 microseconds and 30% higher IOPS. Huawei introduces Data Management Engine, or DME, to ensure automated management throughout the data lifecycle. It automatically collects the running status of all devices to ensure end-to-end storage network awareness. It also predicts and warns about faults to help prevent disasters, and can intelligently analyze information to rapidly locate the root causes of faults. Last but not least, it provides expert suggestions to help users to optimize their systems and achieve end-to-end automated, trusted execution. It's time to choose a fully future-oriented, all-flash-based solution for your data center construction plan. Huawei in this industry is quite highly recognized. Not only garnered the Best of Show Award grand prize at Interop and was recommended as the leading position among global top 5 by DCIG, but has also been listed as a leader by Gartner for 5 years consecutively. We maintain strong growth in the global market, has been chosen by the most customers in China since 2018. We are now serving over 12,000 customers all around the world. Hope that we can have the chance to cooperate in this area. Thank you.
Thanks, Ms. Liang. High-performance computing underpins most industries and is becoming more and more important for decision makers. On top of this, a variety of technologies are using AI and high-performance data analytics. Against this backdrop, we invite Mr. Lu Dejian, Chief Expert in the mass data storage domain, to talk about how next-generation storage accelerates HPC evolution. Let's welcome Mr. Lu.
Hello, everyone. I'm Lu Dejian from Huawei Mass Data Storage Domain. As we all know, more and more HPC applications are using AI and big data technologies to improve efficiency. We know that data plays a critical role, whether AI, big data, or HPC. So storage is becoming more and more important in HPC. What role does storage play? I'd like to share some of my insights to answer this question. It's no secret that HPC is playing a critical role in our society. It has become an important driving force for social progress. For example, we can use HPC to accelerate drug screening and molecular analytics, greatly shortening the R&D period of new drugs. When it comes to automotive industry, HPC helps implement autonomous driving simulation by using data to simulate for diversified scenarios. This greatly reduces cost and time of development. Another example is from genome sequencing. It took 13 years to fully complete the whole genome sequencing at the beginning. But with the help of HPC, we have shortened the time to just 1 day. Remarkable, right? In weather forecast, with HPC, we have a strong feeling that the forecast accuracy is much better than what it was 10 years ago. In recent years, HPC has become even more closely integrated with big data and AI. Data is becoming more important to HPC. This has promoted the HPC industry to evolve from computing-intensive to data-intensive. Let's take a look at the HPC market growth rate on the right. It shows that the data-intensive HPC markets are growing much faster than traditional HPC. Now, let's look at 3 major challenges faced by the HPC industry. The first challenge arises from massive data generated by new technologies and emerging workloads. For example, an autonomous driving test vehicle can generate up to 60 terabytes of data every day. This data must be stored for at least 30 years. The most advanced sequencer can generate 6 terabytes of data each day, which need to be stored forever. In the oil and gas exploration industry, compared with 2 dimensions, 3 dimensions generate over 10 times more data. Ever-growing data volumes will bring big challenges to HPC infrastructure with higher TCO, such as procurement costs, data lifecycle management, rack space, and power consumption. The second challenge comes from hybrid workloads. For traditional applications, they often involve multiple processing phases. These phases usually have a different I/O behaviors. I'll take oil and gas exploration as an example. Seismic data processing requires high bandwidth, while seismic data interpretation needs high OPS. Generally, 2 different storage systems are required to host these 2 types of workloads. As for emerging application, they cause explosive growth in diversified computing, such as GPU, NPU, and FPGA. This further increases the challenges of diversified workloads. The diversity of data access method is another challenge. Let's take autonomous driving as an example. The development process involves multiple phases, such as data import, data pre-processing, model training, and simulation. There are diversified data access protocol interfaces being used in those phases, so time-consuming data migration cannot be avoided. But time is very important to the end-to-end development process. We heard a lot of complaints from our customers for this situation. To sum up, we believe that increased data analysis requirement in the HPC industry create 3 main challenges for storage. First, enterprises find more and more value in massive data. They are willing to store more data for a much longer period. This causes the data volume to grow from petabyte to exabyte level. Consequently, they need a storage system with higher scalability and lower TCO. Second, diversified computing leads to more complex workloads. This requires one storage system to support different types of workloads. Finally, HPDA requires efficient data access in multi-phases, so the same data can be accessed over different protocols without migration. Thanks to continuous investment in HPC, we have built a full-stack infrastructure solution. We focus on development of basic hardware platform, software platform, and professional services. By working with our industry partners, we offer a variety of professional solutions for customers across multi-industries. Storage is an important component for our full-stack HPC solution. With extensive know-how in storage, we aim to unlock HPC potential with extraordinary storage power for a variety of customers. In the past years, we have developed a storage product for different HPC scenarios, such as the OceanStor 9000 series for distributed file system, Fusion Storage for big data. The OceanStor Pacific series we are introducing today is the next generation high-performance storage. It can help customers address new challenges arising from the HPC evolution. It has 3 key features. The first is its high-density design, which increases the capacity and the performance densities to minimize the footprint and TCO. The second feature is that the storage is oriented to hybrid workload for higher performance in all scenarios. And the third is the multi-protocol interworking feature that supports the evolution from HPC to HPDA. Let's take a closer look at how we use these innovations in typical scenarios. First, in scientific research, such as genetic research, genome sequencing generates a huge amount of hot data, which requires extremely high storage performance. After sequencing is complete, cold data need to be carved to an economy storage. Our next generation storage, the OceanStor Pacific, can easily deliver a storage solution for these requirements with optimal TCO. First, compared with general-purpose hardware, the high-density hardware design can reduce cost by over 20%. The OceanStor Pacific 9950 is a high-density performance model. It can provide a bandwidth of 32 GB per second per unit space, delivering excellent performance to deal with massive data. The OceanStor Pacific 9550 is a high-density capacity model. It provides 1.6 petabytes raw capacity in a 5-unit space, which is 2.7 times the capacity density of a traditional high-density server. Second, based on the configured policy, the data tiering feature efficiently and automatically migrates data between a high-density performance pool and a high-density capacity pool without manual interaction. Next, let's look at the oil and gas exploration scenario. As we know, seismic data processing requires high bandwidth, while seismic data interpretation requires high OPS. Traditionally, 2 storage systems need to be deployed to meet the requirement separately. To tackle bandwidth-intensive and OPS-intensive hybrid workloads, we launched OceanFS, which is the next-generation power file system delivering both high bandwidth and high OPS. First, OceanFS distributes metadata on multi-nodes to eliminate the distributed locking overhead. This can reduce the latency by 15%. Second, large and small IOs are separately processed to decrease resource contention. This can reduce the overall overhead by 60%. Third, the dynamic disk indexing technique prevents I/O amplification, reducing the latency about 30%. With these features, OceanFS enables one storage system to fully meet the needs of multiple phases. Finally, let's look at how manufacturing simulation benefits from multi-protocol interworking. In SPDA scenarios, such as autonomous driving development, there may be different data services to be used in phases of pipeline, such as file, object, and HDFS. Traditionally, these three services are separately provided by three storage, meaning data needs to be copied multiple times between devices, causing lots of wasting on time and resource. In contrast, the multi-protocol interworking capability of the OceanStorm Pacific allows one data copy to be shared with multiple protocols. And all data service interfaces are native. The native interface design achieves zero loss of semantics and performance. With the OceanStorm Pacific, we can shorten end-to-end simulation process, reduce the time to market our product. Now, let's review the three major HPC scenarios of the OceanStorm Pacific. In scientific research field, we are always trying to help our customers to reduce TCO. We use a high-density design to reduce both CapEx and OpEx of HPC environment. In oil and gas exploration field, the hybrid workload-oriented design enables one storage system to handle the data produced in multiple phases. It simplifies the management of HPC infrastructure. In manufacturing simulation field, the OceanStorm Pacific can provide file, HDFS, and object service interfaces in one storage. So no data migration is needed. We can shorten end-to-end simulation process, reduce the time to market a product. Huawei will continue to provide our customers most valuable storage solution and working with industry partners for faster and smooth evolution of HPC. That's all. Thank you.